Hi, Integrated Math 1. Welcome to lesson 4.1.3. It's our last lesson, module 4, topic 1, lesson 3. It's the last one in our topic on one variable statistics. So we've talked now that if your data is skewed, whether it's skewed left or right, if your data is skewed at all, then that means, of course, you want to use the median as your measure of central tendency. And that also means that you're going to be looking at the interquartile range to figure out how spread out things are. And then, of course, we've also talked last time about what happens if your data is not skewed, if it's nice and symmetric. If your data is nice and symmetric, of course, then that means that you can totally use the mean. And that means as your measure of central tendency, and that means you're going to want to use your standard deviation as your measure of spread. So we have a couple scenarios here. We're going to be comparing two sets of data, but more importantly, we're going to look at these sets of data and decide, hey, what shape are they? Are they skewed? Are they symmetric? And what does that mean? Should we find the median for each or the mean for each? Should we be finding the interquartile range for each, or should we be finding the standard deviation for each? We want to make sure we have good comparisons. So we're starting off here with activity 3.1. And on activity 3.1, Miss Webb, the spelling bee coach, is preparing her class for their first spelling bee scrimmage. And she needs to determine which student should be the spelling bee captain. The top two spelling bee students' scores are recorded on the table. So here's Maria, here's Heidi. Miss Webb analyzes the scores and calculates the approximate mean score and standard deviation for each student. So actually, we've already been given some pretty good information here. So we're going to advise Miss Webb on who she should choose to captain the spelling bee team. Well, we already know that Miss Webb said she's going to use the mean and the standard deviation. And we're using those because both sets of data are pretty symmetric. We're going with Miss Webb, but of course, if we made a dot plot with these, we would see our data is actually really, really symmetric. So we're going to trust Miss Webb that we've got nice symmetric data, so we need to find the mean and the standard deviation for each. So I'm going to start off with Maria. Let's start with Maria. We're going to find our mean. You know how this goes. In order to find the mean, you need to add all of these up, and this is why I have a calculator. I'm going to add them all up with my trusty calculator. So, 81 plus 73 plus 94 plus 86 plus 70 plus 68 plus 97 plus 93 plus 81 plus 67 plus 85 plus 77 plus 79 plus 103 plus 90. I got a big old number. I got like 1,244. Of course, for mean, we need to divide by how many there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to divide that by 15. And it turns out Maria's mean is about 82.93 is going forever. Now, let's find Maria's standard deviation because we said we're going to find both of those. Now, don't forget to do your standard deviation. Remember that the first step is you're going to subtract your mean from every single one of these to find all of your deviations and then square it. So we're going to do that for every single one of these. Oh my gosh. And it's going to take a little while, but that's okay. That's okay. If you're not in a rush, it's no big deal. Oh my goodness. And you also want to use a calculator. Oh my gosh, please use a calculator. You'll be happier for having done so. You also need a lot of space. They gave you space in your book, and actually they did give you a lot of space in your book, but if you need to bust out some paper, that's 68. If you need to bust out some paper to give yourself a little more space, that's cool. I get it. Like I'm already running out of space here. Oh my gosh. I'm already running out of space. Where am I at? I did 90. I did 68, 97, 93. Here we go. All of them are getting subtracted by the mean because that's how this works. Oh, look, I have another 81. Hey. So we're going to subtract and we're going to square. Where is that? 81. Oh, there we go. We got a few more. 67. I'm going to write them out here. 85, 77, 79, 103, and 90. It's just easier for me. And subtract 82.93 from all of them. Don't mind the fact that my pen sometimes goes funky. Not a big deal. And again, once we subtract, each of these is going to get squared. Always watch out for rounding errors as well, guys. Keep things in your calculator for as long as you can. You'll be grateful you did that. Always a good thing. Oh my gosh. All right, I got this. 81 minus 82.93s forever. And then I'm going to square it. That didn't work so well because I hit a funky button. 81 minus 82.93. And then we're going to square it. There we go. It does work better when I hit the correct button. So I get about 3.737s going forever, something like that. 73 minus 82.93s forever. And then I'll square that, and I get like 98.67. I'm going to go ahead and round some of these guys. I'm going to round that to a 4. I may regret that later on, but you know, hey. 94 minus 82.93s going forever. And we'll square it. Get about actually I take it back, 122.47. 86 minus 82.93s forever. Square it. Get like 9.40. 70 minus 82.93s forever. Square it. Get 167.27. 68, sorry for the bad handwriting, minus 82.93s forever. Square it. I got 223.00. 97 minus 82.93s forever. Square them. 197.87. 93 minus 82.93s forever. Square it. 101.34, round about that. 81 minus 82. Wait, I did this one before. I don't need to do it again. It's 3.74. I already did that one. I don't want to do it again. Let's do the next one. 67 minus 82.93s forever. Helps if I hit the right buttons. And we'll square it. Wow, I got a big number for this one. And then 85 minus 82.93s forever. Square it. 4.27. Takes a while, doesn't it? Square it. Don't forget to square it. Square it. Almost there. And 2 more. 103. Holy crud. Somebody did well that day. Maria did well that day. Good job, Maria. Must have been extra credit on that test. Good for her. And last ones. Last one. Square it. 49.94, something like that. Awesome. All right, we have all of our deviations, but in order to find the standard deviation, we need to add them all up. So I'm going to add all of these up. Sorry, don't get that one. So I'm going to add all these up. 3.74 plus 98.67 plus 122.47 plus, I I feel like this one's wrong. Hang on, I'm going to double check some work. I feel that feels way too big. That is way too big. I did make a mistake. I was like, how is that 7,000? Hang on. I'm going to fix this one. That number is way too big. You probably already caught my mistake, but I'm going to fix it. So it's 253.87. That makes way more sense. Okay. Let's try this again. So 3.74 plus 98.67 plus 122.47 plus 9.40 plus 167.27 plus 223 plus 197.87 plus 101.34 plus 3.74 again, plus 253.87, glad we fixed that, plus 4.27, plus 35.20, plus 119.54, plus 402.67, plus 49.94. And I got a big number, which I should be getting, 1,792.99. Now remember, we're going to subtract by the number we have minus 1. So usually it'd be 15. We divide by 15, but 15 minus 1 is what we're going for. So we're actually going to divide that by 14. And use the calculator. So I'm going to take this number. I'm going to divide it by 14. And then I'm going to take the square root. It looks like my standard deviation is about 11.32-ish. Might be a little bit off because of some of my rounding. In fact, I think it's actually a lot of bit off because I rounded a whole bunch beforehand. So when I used a proper standard deviation calculator, which I did not use here, it did throw me off a little bit. Hang on, let me erase all that. It did throw me off a little bit. I should have actually gotten a standard deviation of 10.61. It probably went off because I was rounding so much, so it threw me off in the end. I would like you to take a moment and do the same thing now for Heidi. Find her mean, find all the deviations, and then find the standard deviation. Go ahead and hit pause to work out Heidi's numbers. Again, your standard deviation might get a little off because of rounding. Don't panic about that. But work out Heidi's mean, work out Heidi's deviations and her standard deviation, and then hit play when you're ready to keep going. So I worked everything out for Maria. I'm letting you work everything out for Heidi. So for Heidi, I found that she actually had the same mean. When I added these up and divided by 15, I still got 82.93. But her standard deviation was bigger. So when I worked it out, her standard deviation ended up being about 16.75. And again, yours might be off if you were rounding early like we were doing earlier. So when I'm comparing these two ladies, I notice that the mean is the same. So it's not a really good to use to compare them, right? I mean, they have the same mean, so that doesn't tell me who should be captain. But I'm going to check out these standard deviations. Maria has a smaller standard deviation. That means that her information, her data, was more clustered around the mean. It was closer to that mean. So that means she was more consistent. Heidi's was a bit more spread out. So with that in mind, then, I would say that Maria should be the spelling bee champion. They have the same mean, but Maria's scores had a smaller standard deviation. So she was more consistent in her scoring, more consistently a good speller. Good for Maria. Let's compare some airlines, shall we? Data were collected from two rival airlines measuring the difference in the stated departure times and the times the flights actually departed. The average departure times were recorded for each month for 1 year. The results are shown in these lovely tables here. So you're scheduling a flight for an important meeting, and you must be there on time. Which airline would you schedule with? Explain your reasoning. So start by taking a look at your data. Is it symmetric? Is it skewed? That's what I would start with. Maybe make some dot plots, something like that. And then depending on whether you see symmetric or skewed, that tells you mean or median, and that means that will tell you whether you should be doing the interquartile range or the standard deviation for your spread. So go ahead, hit pause, take a look at your data, decide what you want to do, and then hit play to keep going. All right, so I don't know about you, but I actually did a histogram. I didn't even do a dot plot for this. I did a histogram. I just felt it was easier. So 10, and I'm going to count by 10, 10, 20, 30, 40. Did we go over that? No, we're already here. I'll go ahead and go up to 50 now. So 1, 2, 3, 4, 5, 6. I don't know if I need more than that. So between 0 and 10, I've got 1, 2 that were between 0 and 10. So there's my first bar on my histogram. Between 10 and 20, okay, so 1, 2, 3, 4, 5. Oh my gosh, that went way up there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. 5. Choo, choo, choo. Here's my next bar. Between 20 and 30, actually, I probably shouldn't have counted the 20s for that, huh? I'm gonna fix that. So let's not count the 20s. Let's count between 10 and 20. So that means that would just be 1, 2, 3. So I'm just gonna go up to 3. And we'll put the 20s in the next category. So anything that's 20-something. 1, 2, 3. Got 3 more of those. Choo, oh, choo, choo, choo. Anything 30 to 40, so anything in the 30s, 1, 2, 3, and then I've got a 40, and there's only one of them. That's pretty symmetric. That's pretty darn symmetric. I would say that's pretty symmetric. So let's see what's going on with our fly high airlines, though. We need to be able to make sure they're both symmetric if that's what I want to use. 10, 20, 30, 40, 50. I know I lost my 30. Hang on. All right, so 0 to 10, 1, 2 of those. I got 2 of those. Choo, choo, choo. Anything in the teens? 1, 2, 3. So again, go up 3. Anything that's 20-something? 1, 2, 3 of those. Again, lots of 3s here. Anything in the 30s? 1, 2. Oopsie, just kidding. And I got a couple in the 40s. 1, 2. I just have 2. You know, this data also looks pretty symmetric. I mean, there's a little bit of a lean to it, but nothing extreme. So you know what? Since both of these are symmetric, that means I'm going to use the mean and the standard deviation. So I'm going to go ahead and erase these. Since they're pretty symmetric, let's go ahead and use the mean and the standard deviation. Mean is easy, right? You got to add all these up. If you add them all up and divide by how many there are, so 26 plus 15 plus, 20, I can do this. 26 plus 15 plus 40 plus 0 plus 20 plus 33 plus 20 plus 5 plus 19 plus 34 plus 11 plus 33. Looks like I got 256. And of course, we're dividing it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to divide that by 12. And we get about 21.3s forever. So 21.3 is going forever. Of course, you're going to use this to help you do your standard deviation. So every single one of these, you need to subtract that out and square it, add them together, divide by 11, and do the square root. Due to not wanting to make this video ridiculously long, I'm not going to do that here. Hopefully you did that on your paper. And of course, if you're like, Miss Scott, how did you get the number? Feel free to hit me up for it. I can go over it with you. That's cool. So for my error, the mean was 21.3. And when I subtracted my mean from all of them, squared each one, added those deviations together, and divided by 11, because right, 12 minus 1 is 11. And then, of course, did the square root. I got about 11.83. You could do the same thing. We're going to do the same thing for fly high airlines. If I add all these up, 14 plus 32 plus 29 plus 8 plus 24 plus 45 plus 7 plus 30 plus 15 plus 49 plus 16 plus 27. I got a little bit higher mean. I got 296. Oh my. And of course, if I divide that by 12, because there's 12 of these, I get about 24.6 is going forever. Then I use this, I subtract from all of these. If you want to, you can even show the work, right? That'll be good. So I'm going to subtract from every single one of these, and I'm going to round it to 24.7. But you know it goes, you round early, and it's going to mess things up in the end. So I'm going to subtract every single one of these. Every single one of these. I can't even. Oh my gosh. So subtract every single one. And then you're going to square every single one. You're going to square what you subtract. You're going to add them all together, divide by 11, and do the square root. And that means that your standard deviation ends up being about 12.86. So I'm looking at this, and I'm having two thoughts on this. My first thought is that the mean for my error is lower. That's my first thing that I notice. And I'm like, dude, if the mean is less, then I'm already leaning towards my airlines. Like I just am, right? I don't want to be late. I want to depart on time. I'm also noticing that the standard deviation for my airlines is lower, which means not only do they have a lower mean, they were more consistent about hitting that mean. So you know what? I'm going with my airlines. Yeah. The mean and the standard deviation looks much better. I have a lower mean. I have a tighter standard deviation that's less spread out. Oh my gosh. Yeah, I'm going with my airlines. Good call. Last activity. Brenda needs to get the oil changed in her car, but she hates to wait. Many of us do. Quick Change and Speedy Oil are two garages near Brenda's house. She decides to check an online site that allows customers to comment on the service at different local businesses and record their wait times. So Brenda chooses 12 customers at random for each garage, and the wait times for each garage are shown. So based on the data gathered, which garage should Brenda choose if she's in a hurry? So first things first, look at the symmetry of your data. That's going to be the first thing you want to look at. The next thing you're going to do then is decide, should you find the median or should you find the mean? If you find the median, find the interquartile range. If you find the mean, find the standard deviations. Go ahead and hit pause, work this out, and then hit play to check your work. So I went ahead and I tried to make a dot plot for this. So if I did a dot plot for quick change, I was like, I'm going to do a dot plot for quick change. So I'm going to call it QC. 10, 15, 20, 25, 30, 35, 40, 45, 50. 55, 60. Because I see a 60 way up there. So I'm like, that's 60. I'm like, that's 10. 2, 3, 4. 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I know, it seems like a lot of work just to figure out the symmetry of your data, huh? It's all good. So 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. All right, so I have a 10, make a quick dot plot, 10. I have 60, oh my goodness. I have a 22, I have a 15, I have a 12, 24, that's over here, 20, 18, 16, 23, you might be noticing something here, 23, I think that's like there, another 22, oh, stack that mess, and another 15. So I don't know about you guys, but it looks like my data, because I have this weird over here, my data is way skewed. And in fact, that little guy there is pulling to the right, so I'm going to say it's skewed right. This would have been pretty symmetric if it weren't for this guy pulling to the right, so we're going to say it's skewed right. So without even looking at the other one, this says to me we should be using the median. This says to me we should be using the median to figure out which one's the best one to use. So I've clearly got some skewed data going on here. So that says, fine, let's do the median, let's do the interquartile range. Now, please don't forget that you need to put these in order before you find your median and your interquartile range. Again, take a minute to find those. Go ahead and hit pause, work it out, hit play when you're ready to check your work. All right. So let's start with quick change. I'm going to put these guys in order. I've got 10, 12. Again, it helps if I cross them out as I go. I've got two 15s, 15, 15. So I got a 16. I've got a 22 and a 22. Oh, no, I missed a 20. So I have a 20, a 22, and a 22. I hate it when that happens. I got a 23, a 24, and a 60. All right, we know minimum and maximum. Those are fine. Let's find the guy in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm not doing well here. I need my fingers. It looks like 20 is sitting in the middle. So there's my median. My median is 20. As it should be. Fair enough. No, because I forgot one. No, that's not my median. I forgot one. There's an 18 in there. Oopsie. Hang on, I'm going to come here. There's an 18 and a 20. Oh, crud. That's okay. That's an easy fix. And that means that my median is actually 19 because it sits in between. So cool, there's my median. Interquartile range means I need my quartiles. So boom, boom, boom. It looks like the middle here then is going to be 15. So my first quartile is 15. That means then that my third quartile is going to be right here. So that's 22.5. So my median, so for quick change, my median is 19. And let's do some quick work over here. If we want to do our interquartile range, we need to do 22.5 minus 15. That's why I have a calculator, despite the fact that I just threw my earbuds with the mic like across the table. Sorry, guys. So 22.5 minus 15, I get about 7.5. So it looks like for quick change, my median is 19, my interquartile range is 7.5. I'm going to go ahead and erase this and then put it up nice and neat here on the slide. Boom. And now let's do the same thing for speedy oil. Again, let's go ahead and put them in order. I've got a 5. And then we jump to 24 and 26. 24, 26. I've got two 30s and a 32. Boom, boom, boom. I got a 40 and two 45, so 40, 45, 45. So boom, boom, boom. I got a 55. I have a 60. I have an 85. Oh my gosh. Somebody waited almost an hour and a half to get their oil changed. Oh my gosh. All right, you know this goes. There's your minimum. There's your maximum. The median is going to be sitting somewhere right in the middle. So boom, 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 boom. So my median is going to be sitting between 32 and 40. The exact middle between 32 and 40 is 36. Haha. So it looks like my median is 36. Excellent. Of course, I need to find my quartiles. It looks like quartile 1 is between 26 and 30, so that would be 28. It looks like quartile 3 is going to be between 45 and 55, so that would make it 50. So if I want to find my interquartile range, I will do 50. I will subtract 28. I will use my calculator. 50 minus 28, and I got 22. So I'm going to erase this so I can write it nice and neat on my screen here. So for speedy oil, my median was 36, and the interquartile range was 22. So I'm in a hurry. Guys, not only does quick change have the smaller median, the lower median, it has the smaller and tighter interquartile range. So not only was their measure of central tendency smaller, it was more compact. They were more consistent about getting it done in 19 minutes. So I'm going to go with quick. I think Brenda should go with quick change. If she's in a hurry, the median's lower, and also the interquartile range is smaller. More consistent, definitely. As always, guys, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, talk to me. Email me. Come see me during office hours. Click the magic Ask for Help button if you're in a Zoom breakout room. I'll come. And I'll see you guys later. Bye.